Hello friends, my name is Sonali Jangale. I am studying in B.Sc second year from Adarsh College, Jangale. Today I am presenting a theorem. The statement of theorem is Cauchy's first theorem on limit. Now we shall prove the Cauchy's first theorem on limit. Now what is the Cauchy's first theorem? So if an is a sequence which is convergent, means if limit n tends to infinity an is equals to L, then another sequence Sn will also convergent to same limit L, where Sn is equals to a1 plus a2 plus up to an upon n. Okay, so this is the statement of Cauchy's first theorem. Now I am going to proof of the theorem. Given limit n tends to infinity, an is equals to L. So let another sequence Bn whose n term is Bn is equals to an minus L. So limit n tends to infinity, Bn is equals to limit n tends to infinity an minus L. So here since limit n tends to infinity, an is equals to L by 1. So this equals to L minus L is equals to 0, implies limit n tends to infinity, Bn is equals to 0, means the new sequence Bn is convergent and converges to 0, implies sequence Bn is a null sequence. Now form 2, here Bn is equals to an minus L. So we put n is equals to 1, n is equals to 2 up to n. So we get b1 is equals to a1 minus L, b2 is equals to a2 minus L, up to bn is equals to an minus L. By substituting these values, so we get b1 plus b2 up to bn is equals to a1 minus L plus a2 minus L plus up to an minus L. So here a1 plus a2 plus up to an minus nl. So on dividing by n, we get b1 plus b2 up to bn upon n is equals to a1 plus a2 plus a3 up to an minus l upon n, or a1 plus a2 plus up to an upon n is equals to b1 plus b2 plus up to bn upon n plus 1. Now I am taking limit n tends to infinity, a1 plus a2 plus up to an upon n is equals to limit n tends to infinity, b1 plus b2 up to bn upon n plus 1. Now we need to show second term of right hand side is 0, so that limit n tends to infinity, b1 plus b2 up to bn upon n is equals to 0. Now sequence bn is bounded. Therefore mod of bn less than k for all n. Therefore given epsilon greater than 0, there exists m belongs to n such that mod of bn is less than epsilon for all n greater than or equal to m. Now mod of b1 plus b2 up to bn upon n is equals to 0. So is equals to mod of b1 plus b2 up to bn plus bm plus 1 bm plus 2 up to bn. Since m is less than n, so we get divided in two parts. Mod of b1 plus b2 up to bn upon n is less than or equal to mod of b1 plus b2 up to bm upon n plus mod of b1 plus 1 bm plus 2 up to bn upon n is less than or equal to mod of bn b2 plus bm plus mod of bm plus 1 bm plus 2 up to bn. So we have two equations 5 and 6. We get m epsilon upon n plus n minus m upon n k, m epsilon upon n plus 1 minus m upon n, k is equals to epsilon dash. Let's suppose this is epsilon dash, means implies mod of b1 plus b2 up to bn upon n minus 0 epsilon dash implies limit n tends to infinity, bm plus b2 plus up to bn upon n is equals to 0. Now substituting this value in equation 4, so we get therefore limit a1 plus a2 plus up to an upon n is equals to L, and his proof. Thanks for watching.